Laws of photoelectric emission. For a given photosensitive material and frequency of incident radiation above the threshold frequency, the photoelectric current is directly proportional to intensity of incident radiation. It means if this axis is photoelectric current and this is intensity, then we can say that photoelectric current is proportional to intensity. That is why the graph is like this. This axis represents photoelectric current and this axis represents intensity. So graph will be like this, which is linear. Now, second point, for a given photosensitive material and frequency of incident radiation, saturation current is found to be proportional to the intensity of incident radiation. Here, three intensities are shown and this axis represents photoelectric current, so which is higher for higher frequency, but energy possessed by photoelectrons is same because stopping potential for all three types of radiations having different intensities is same. Now, for a given photosensitive material, there exists a certain minimum cutoff frequency of the incident radiation called threshold frequency. As you know very well that below this frequency, photoelectric emission will not occur. And if incident radiation has larger frequency than this value, in that case, photoelectrons will emit. And that we have already studied from Einstein photoelectric equation that h nu equal to h nu 0 plus kinetic energy. So photoelectric effect will occur only when incident photon have energy h nu greater than h nu 0, which is threshold energy of the photosensitive metal. So here the same thing is explained. Above the threshold frequency, the stopping potential or equivalently the maximum kinetic energy of the emitted photoelectron increases linearly with frequency of the incident radiation. If you remember the graph, if frequency, saturation current for all frequencies are almost same, but suppose frequency is nu 1, so stopping potential is suppose minus V01. If frequency is increased, then saturation current will remain same, but stopping potential will increase. It means more energetic radiations will be. So minus V02. Similarly, if we take frequency, this is nu 2. If we take one more frequency, suppose nu 3, in that case, stopping potential will be more. Here, order of frequency is nu 1 is less than, nu 2 is less than nu 3. So here, the same thing is explained that the maximum kinetic energy of the emitted photoelectron increases linearly with the frequency of the incident radiation, but is independent of the intensity. Here, one more thing. For metal A, the threshold frequency is nu 01. So till this frequency, no electron will emit, but after that, there is a linear relation, means stopping potential is increasing. It means ejected electrons will have more kinetic energy. For this line shows the graph for another metal whose threshold frequency is larger than the metal A. And after that, when this energy of incidental radiation increases beyond nu 0, h nu 02, that is, this is threshold frequency. So work function for this metal will be h nu 02. And if the energy of the incidental radiation is greater than this value, then photoelectric electrons will emit and the graph will look like this. This is stopping potential axis and this is frequency. And the last point or last law is that photoelectric emission is an instantaneous process. It means it takes no time, almost 10 power minus 9 second, which is negligibly small, even when the incident radiation is made exceedingly dim. So we can say that if frequency is above the threshold frequency, in that case, intensity does not matter. Whatever intensity the radiation may persist, still photoelectric emission will occur and it takes no time. Thank you for watching.